Hey guys, here's a video on different properties, postulates, rules that kind of form the whole foundation of math. And they help you solve equations and help you understand why things are the way they are. So first of all, let's talk about the addition property. So the addition property says if you've got a scale like this, and on this side you've got an x, and on this side you've got an x, well, you can add something to both sides. You can add a couple dots, and you can add a couple dots. You can add a y, you can add a y, and it's going to stay balanced. So the way this is going to appear, the way you're going to see it is this. You're going to have a question like this. X minus 2 equals 10. Underneath it, it's going to say x equals 12, and it'll say what property allows you to go from this first step to the second step. And what happened here is we have x minus 2 equals 10. Underneath, we have x equals 12. Well, what happened? That minus 2 disappeared, and it disappeared because we added 2 to both sides. So on this one, don't get caught up by looking at this minus sign. What you need to look at is how did I get from that step to that step? And the way we did this is by adding 2 to both sides. Okay, so that's the addition property. Let's move along and talk about the subtraction property. Well, just like before, going back to our scale, if you've got a scale like this, and you've got an x, and you've got an x, and you've got a couple of dots, and you've got a couple of dots, well, you can actually go through here with an eraser, and you can erase a dot and erase a dot. You can take away an x, and you can take away an x. You can take away a dot and take away a dot. That's called the subtraction property. So you're going to see it in cases like this. Let's say you've got x plus 2 equals 6. Underneath, you've got x equals 4. Well, how did you get from here to here? You got rid of that positive 2 because you subtracted. So again, just like before, don't fixate on this sign. It doesn't matter that's a plus. Fixate on how did I get from the first step to the second step, and that's with subtraction. All right, that's subtraction. Now the other ones kind of make sense. We've got multiplication. And multiplication, this one I'm going to put a star by because it always trips people up. Multiplication is going to look like this. You've got x over 2 equals 5. Now people, again, will say, oh, I see a division sign. It must be division property. No, keep on watching and see what happens. Underneath, you have x equals 10. So how did you get from here to here? Well, how did you get from 5 to 10? You got there by multiplying 2. How do we get rid of that divided by 2? We got rid of the divide by 2 by multiplying 2, and then that canceled. So again, on this one, take a look again. You have division, and we undid. The opposite of division is multiplication, and that gets us x by itself. So that's the multiplication property. And finally, you've got division. Division property is like this. You have 2x equals, let's do 18, and you divide both sides by 2, and you have x equals 9. So the way you got from 2x equals 18 to x equals 9, the way you got from there to there is by doing division. Okay, so those are all properties that relate to doing things to a scale. You can, if you have an x, you can triple it. And now I've got 3 x's on both sides. You can divide both sides. So doubling, tripling, as long as you do it to both sides, it's going to stay balanced. Okay, now let's talk about a few other properties, and these ones are going to be really self-apparent, and you're going to wonder why are we learning these. And these, again, what we're doing is we're laying the foundation for math. Math is building on these properties. First of all, reflexive. Now this one is the most straightforward. Anything is equal to itself. A is equal to itself. And in geometry, any line segment, like line segment AB, is going to be congruent to itself. So anything is equal to itself. Again, another geometry example, if we have angle M is going to be congruent to angle M. Any number is equal to itself, any angle is congruent to itself. So that is the reflexive property. Just to keep it simple, I'm only going to be talking about the equality, but no, this also applies to geometry. That is reflexive. Next one is symmetric. Symmetric goes like this. If A is equal to B, then B is equal to A. And you see this a lot, you do a equation, you get down to the very bottom, and you get 5 equals x. And you're like, that doesn't look very pretty. I'm going to rewrite this as x equals 5. When you're doing that, you're using the symmetric property. You can kind of see the symmetry, right? Imagine like a butterfly. You got 5, and you got 5, and x, and it's a butterfly. It's symmetric. So that's called the symmetric property, and the name sort of makes sense. And the next one is the transitive property. So transitive property goes like this. If A is equal to B, and if B is equal to C, then that means that A is equal to C. So, for example, if everyone from Canada is polite, and if my cousin Alan is Canadian, then my cousin Alan is, you guessed it, very polite. We're using the transitive property. If A is equal to B, and if B is equal to C, then A is equal to C. So all those things are connected together. So that is the transitive property. Now, there's a way to remember these that is really helpful. Reflexive property has to do with one thing, one object, and one equals sign, okay? Only one object, one equal sign. Symmetric property, we have two distinct things. A and B are two distinct things. And when we write about it and give examples, we'll have two equal signs. Okay, so two things, two equals signs. And the transitive property, you guessed it, transitive property has A, B, and C. So A, B, C, these are three distinct objects, A, B, and C, and you also have 1, 2, and 3 equal signs. So if you see a question that involves 3 equal signs, 3 different objects, you can guess based off of these, out of the 3, it's going to be the transitive. So this guy, you have 3 things, 3 distinct objects, A, B, and C, and 3 equal signs. So that's a way of differentiating between reflexive, symmetric, transitive. Reflexive, anything's equal to itself. Symmetric means you can flip it around symmetrically like a butterfly. Transitive, to trans means to go across. A crosses to B, B crosses C. You're crossing across all those different equalities. Okay, now another property, we've got substitution. So substitution, imagine this in terms of a sports analogy. You've got a ball game, and we've got y on the field. We've got 5 being multiplied by x plus 7 over x. And x in the ball game gets injured, sprains its ankle, can't play anymore. But sitting on the bench, you have player whose value, let's do a different one. Let's do 9. So what we're going to do is we're going to say x and 9 play the same position, so 9 is going to go in wherever x was. So wherever we say x in, we're going to substitute in. The coach says, I'm subbing you in 9, and so 9 is going to go there in place of the x's. So 5, we've got 9 plus 7 and 9. Let me put this in purple so you can see. So wherever we saw an x, I'm writing a 9. Wherever we saw an x, I'm writing a 9. So 9 is substituting in there. So that's the substitution property. And finally, the last of the properties is called distributive property. And distributive property gets rid of parentheses. Basically, if I have 3 parentheses x plus 2, what that means is I can do this. I can do 3 times x and get 3x, and I can do 3 times 2, and I can get 6. So 3x plus 6. So that's the distributive property. So if you see parentheses and then you don't, then it's the distributive property. Again, if you see parentheses in the first step and then you don't, it's the distributive property. Okay, now, while we're here, let's go over a couple really short postulates in geometry we're going to be using a bunch. And these, again, are super straightforward. Again, what we're doing is we're not trying to prove anything new. We're just trying to get a benchmark of things we can all agree are true without proof. Then everything in geometry and algebra can kind of prove from these things. So, first one is called the segment addition postulate. Segment addition postulate. And the way this goes is this. I've got A, I've got B, and I've got C. They're all along this line. Now let's say the distance from A to B is 7, and the distance from B to C is 2, then I would say the distance from A to C is 9. Again, like I said, we're not trying to prove anything new here. We're just getting a name for something we already know to be true. So let's write this out. AB, and now that means, with no line over it, means the distance from A to B, the distance from A to B plus the distance from B to C is equal to the distance from A to C. Okay, so underneath you'd say distance from A to B is 7, distance from B to C is 2, add that up, distance from A to C is 9. Okay, and you're going to see this, just for fun, they like to mix in a bit of algebra here. So you're going to see something like this. It's going to say something like 3x, and it's going to be 2x, and then the whole thing they're going to say is 15. And so you set up something like this. You're going to say 3x plus 2x, that chunk plus that chunk adds up to be that chunk 15. And now you combine some like terms, and then you get x is 3, and that's kind of what they're looking for on those guys. Okay, now that's the segment addition. Something really similar is called the angle addition postulate. And it's the same thing, just with angles. Let me just give you a really intuitive thing to begin with. Let's say you've got a 90 here. So you've got a 90-degree angle. The 90-degree angle right here, we're going to break it apart, and that's going to be 70, and we could do 20, 70 and 20. We could also break this up differently, and we could say this is 45 and 45, and the 45 and the 45 make 90. So let's define this a little bit more rigorously. Let's say you have something like this. This is A, this is B, this is C. We're going to call this guy D. So the angle addition postulate says, and I'm going to put this in colors, this angle right here, that angle is called angle. We start at A, we move to B, we end at D. So A, B, D. As we say those three letters, we trace out that angle. So angle A, B, D. Now in red, we've got this angle. We start at D, we go to B, we go to C. So DBC means this angle. Angle DBC. And what can we say about those angles? We can say they add up to be the big angle, and the big angle is going to be angle ABC. ABC. ABC traces out that big angle, ABC. So we've got the blue angle plus the red angle. Blue angle plus the red angle add up to be equal to the big angle like that. Again, one more time, just intuitively, let's say you've got something like this that's 90. We can break it up into 20 and 70. Or we can break this up into 10 and 80. They're going to add up to the same thing. And like the one before, they're going to mix in some algebra here just for fun, just to keep it real. They're going to have something like 3x and 2x, and this is 90, so your equation will be something like 3x plus 2x equals 90, and you're going to add those together to be 5x equals 90, and you're going to divide both of those by 5 to find out what your x value is. Okay, that's it. Those are all the postulates and theorems and things that we need to get our geometry off to a good foundation.